You see in this YouTube picture a solar system with sun in the center and 4 inner planets and 4 other planets. They are rotating, you see. But if you look for Jupiter, for example, you can see that it not only rotates for sun, but it spins. It rotated in the some line perpendicular to the plane of the solar system. This is the picture when rotating, when Earth is in rest. You see that the planets and sun have a very interesting rotational motion. It is best described by Sir Edmund Whittaker in his lecture in Royal Society. You must know that Edmund Whittaker was also a member of our academy, PAS. He was a great admirer of the Big Bang theory. More admirer than Lemaitre himself. And he described in very beautiful words the problem of rotation. I will read this. In his essay, Spin in the Universe, he wrote, rotation is a universal phenomenon. The Earth and the other members of the solar system rotate on their axis. The satellites revolve around the planets revolve around the sun, and the sun himself is a member of galaxy or Milky Way system which revolves in a very remarkable way. How did all this rotary motion come into being? What secures their permanence or brings about their modification? And what part do they play in the system of the world? It is necessary to point that it is not the only rotational motion in which participate sun and planets. The whole solar system is rotating with respect to the center of the galaxy. And galaxy probably also, as a whole, rotates in some center. But all the origin of this rotational system always was some very difficult point of cosmogony. Usually there was proposed some hypothesis about origin of the rotation, which I think does not correspond to reality. The reason is interesting. The reason, the main reason for the difficulty lies in the fact that probably classical mechanics cannot explain the origin of this rotation. And the only way to understand this is using quantum mechanical laws for the rotation, namely, I mean the Rage-like law for the connection between rotational moment, angular moment, or spin, and mass of the object. My talk is devoted to the solution of the problem of rotation in universe, and particularly in Big Bang theory, using Rage to approach devised for quantum particle physics. Here is something which I was told you, and here in other quotation is from journalists who describe also the impetus rotation of for Big Bang theory. He said that galaxy rotation and how it got started is one of the great mysteries of the astrophysics. In a Big Bang universe, linear, straight line, non-turning motions are easy to explain. They result from the bang. But what started the rotary motion? To convert linear motion to the rotary, one usually takes some trickery. This is, as I know, is a journalist, Thompson, Dietrich Thompson. For this reason, I prefer to classify the difficulty of this rotation as by comparison with the famous personage Cinderella. Rotation is in some sense is a Cinderella of the Big Bang theory, because until now there was no proposed, no solution for the rotation problem. The origin of rotation or spin of cosmic bodies is most significant problem in physics and astrophysics. Our understanding of universe is incomplete without understanding the source of spin or angular momentum of cosmic bodies. Spin and angular momentum is conserved quantity. Since their total amount in the whole universe must be constant. Rotation cannot appear or disappear spontaneously, but it is an inborn, primordial, permanent, and fundamental entity. Here you see the the proposals for the possible solution of the rotation, which I think have only historical meaning, historical sense. This was the first is the Fred Hoyle and Peebles point of view that that rotation is originated from the interaction of non-symmetric clouds which originate during the Big Bang. but it is not a very probable mechanism. Other mechanism was proposed by Weizsäcker and Gamow and connected with some primordial turbulence, which is not clear how this turbulence is originated. What I am going to show you is that the success of Reggie theory in last years in physics of elementary particles permit to explain the origin of rotation in completely different way. In 1962, Geoffrey Chew discovered very interesting connection between invariant spin and mass. This connection has this so-called Reggie dependence. You see this the last line. G is proportional to square of the mass. Later I will discuss this formula and its generalizations. Once more, it is necessary to point that to stress that the creation of spin or angular momentum is impossible by application of classical field. You can create spin classically only by so-called torque. Torque when you have a pair of forces. Simple force cannot, one force cannot give the result in rotation. The understanding of spin cannot be achieved by focusing only on classical side of the subject, but instead it is necessary to some interdisciplinary quantum mechanical vision of this problem. Without invoking quantum mechanical concepts, the rotation problem cannot be solved. Consider from classical mechanics, from the point of view of relativistic classical mechanics, the angular momentum of so-called relativistic string, or one-dimensional object, which also name it n-brane. To analyze this object, it is necessary to introduce it is necessary to introduce two variables. The angular momentum depends on the energy, and the square of energy, like square of the energy, and here there is some parameter with the dimension of force, which termed tension. This variable has some such dimensions, because the simplest way to analyze, to derive this formula is using dimensional analysis. By the fact, this exact formula for angular momentum, one-dimensional object, where with S square dependence, it is this is obtained. This is exact formula. It is obtained by integration of rotational motion of the one-dimensional object. But dimensional analysis gives also almost exact result without this constant 2p, without except this constant 2p. For this, we use the dimensions, make usual dimensional analysis, and will obtain this formula. For general case of n-dimensional object, not string, but membrane and three-dimensional brane or three brane, we can solve using dimensional analysis using the dimension of tension for n-dimensional object. He has dimension of energy divided by L by the unit L in power n. For if you remember, for one-dimensional object, n equal 1. And general formula looks like this. And if we substitute instead mc square, obtain the second line, the second part of this formula. I ask you to take into account that the dependence of the angular momentum from energy for n-dimensional object is energy in power 1 plus 1 divided by n, or proportional to with the same exponent to the mass. Mass in 1 plus 1 divided by n. It is important for this approach. Later we will see that there is interesting connection very interesting connection with the musical scale of Pythagoras, with this connected with this exponent. It is necessary to stress that tension has a dimension of force, yes, and can be measured in Newton. Using this, for example, let's calculate the tension, gravitational tension, gravitational Planck tension, or so-called Planck tension. If we introduce Planck mass and Planck length, then gravitational tension is equal to the force between to the gravitational force between two Planck particles, Gm square divided na L square. Yes, if we substitute these values of L Planck and Planck, we obtain interesting relation. The Planck tension is C in 4 power divided by G. This is enormous. This is an enormous force. The Planck force, Planck tension, not force, Planck tension, equal to 10 in 44 degree Newton, or 10 in 40 ton force. This tension is a tension, for example, any black hole, rotating black hole. If rotating black hole is approximated by rotating string, one-dimensional, one brane, yes, then we using using this simple consideration, we obtain the usual Kerr black hole angular momentum as Gm squared divided by C. Yes? Here. This combination Z squared divided by G, the tension of gravitational tension, is important in Einstein equation. This is a factor before the energy momentum tensor in Einstein equation. It is interesting that in other powers of C, all this G divided or C in the different powers have some specific physical meaning. I will remind you. I will remind you the spin-mass relation for n-dimensional object. Using Regge formula and this dimensional consideration, the general formula for n-dimensional object, the connection of, between spin and mass is the following. When n corresponds to this, n equal 1 corresponds to the string, 2 corresponds to the membrane or two-brane, and 3 corresponds to the three-brane or symmetric object. You see the particular exponents have the value for string, it is square 2, for membrane two-dimensional 3/2, and for three-dimensional three-brane 4 divided by 3. This is the Pythagorean intervals. We will see a little later. Now, let's consider the application of this formula to the real physical world. In this picture, in this graphic, you see observational data for spin mass dependence for all known celestial objects, and also here is indicated proton. Here, this corresponds to the highest planets, stars, globular clusters, and further galaxies and clusters of galaxies, and the whole universe maybe itself. Here, there is no any application, no theoretical consideration. This is pure experimental numbers. And the second graph show the theoretical construct. It is pure theoretical construct without any observational data. You see here the three lines for n equal 1, n equal 2, n equal 3 for this formula for n-dimensional Regge formula. The dotted this line correspond to the Kerr black hole. You can see that this Kerr black hole intercept these two lines in two different points, and it is parallel to the m square line. We show that indeed the Kerr black hole has Gm square divided by C behavior. These points of intercept of black holes with membrane, he cannot intercept with n equal 1, n square, because it is parallel. But he intercepts these two lines in 2 points, which I call, this is a Chandrasekhar point, this is Eddington point. The Chandrasekhar point has coordinates in mass. The mass is Chandrasekhar mass. You see, this is Chandrasekhar mass. The first. And the intercept with this axis is corresponds to the limiting angular momentum for stars. This is the must be considered together with Chandrasekhar mass as one formula with the same origin. And the Eddington point has for mass this relation, which is well-known relation for universe, to the mass of universe proposed by Eddington. And the corresponding angular momentum is here, is for Eddington point. And this is the angular mass and possible angular momentum of the universe. Now, this was you can find in my previous talks more detailed discussion of this. Now let's consider some predictions for planets. For Jupiter, you have for Jupiter experimental or observational mass in kilogram. Yes, 10 in 27 kilogram, and observed angular momentum in this C units. This is equal. This units can be written as joule multiplied by second instead of kilogram meter square. Now the Jupiter is described by three-dimensional formula with exponent 4 divided by 3. If we take this formula and substitute mass of Jupiter, we obtain almost exactly the experimental observable value for the angular momentum, 10 in 38 joule multiplied by second. The same is true for Earth and Earth-Moon system. They also use formula 4.3, and the prediction is very good. If we substitute here the mass of Earth, we obtain the angular momentum for Earth-Moon system, almost exactly. The Sun, the angular momentum of Sun and solar system also can be calculated in this way. The galaxies, M51 Galaxy is the so-called Whirlpool Galaxy. No. The Whirlpool Galaxy is described by the formula with the exponent 3/2 for strings, for disk, two-dimensional, or two-brane. And we see the numbers are concise, almost concise predictions. The same is true for our Milky Way galaxy. Milky Way galaxy, also 3.5, and this is the prediction in comparison with observational data. Also, for the large clusters, for common clusters, there is a good coincidence between theoretical prediction and observational data. Now, I would like to pass to some philosophical consideration. To discuss the meaning of this exponent, which define the spin mass dependence for celestial objects. It is interesting that here is these numbers are connected with Tetractys numbers, with values of ratios in this Pythagorean symbol of Tetractys. You know that Pythagoras used this Tetractys for constructing the musical scale, which is valid until now. Philosophically, the Pythagoreans believed that the God communicated with men through numbers. This Tetractys has a meaning. Here is the Pythagoras bust, which we can see in Vatican Museum. The Tetractys represented in some sense, organization of space, one-dimensional space, two-dimensional, three-dimensional. 1 point correspond to generator of dimensions, and 2 points to the line, 3 points to the triangle, and 4 points to the tetrahedron or solid body. And Pythagoreans very seriously considered these ratios in Tetractys. They pride to this Tetractys during their everyday meetings. Yes, and really, it has sense because these numbers are very important in defining perfect intervals in musical scale. The 4/3 is a perfect fourth, 3/2 perfect fifth, and 2 is octave. This is, if you remember, exactly the exponents of these 3 lines in the graphic for cosmic objects. 2 at usual Regge formula for hadrons, 3/2 generalized Regge formula for galaxies, and 4/3 corresponds to the stars. This is 4/3 is a perfect fourth, 3/4 is perfect fifth in musical scale, and 2 is octave. If you consider, we can return to this exponent 1 divided 1n, he generates this the same Pythagorean numbers, 2, 3/2, 4, 3. Yes. What does it mean? Why hadrons have a scaling exponent square and galaxies 3.5 and stars 4.3? Why they coincide with musical intervals? Who knows? This indicate, but we can say that this indicate that Tetractys is a very rich transcendental symbol that which embrace profoundly deep relationship, the relationship between musical intervals.
Professor, we are left only with 5 minutes for questions, so if you can round up your conference, I'll appreciate it.
What?
Sure, I'll appreciate it.
I have no time?
Well, it's, yeah, it's
5 minutes.
5 minutes, okay.
Conclusion. We have presented a quantum mechanical model for the origin of angular momentum. Unlike other classical attempts, our approach gives accurate numerical predictions of angular momentum for all spinning astrophysical objects. This is occur in my opinion, a first time in the history of physics and astronomy. And from other point of view, this show that the behavior, the angular mass, angular spin connection for hadrons, galaxies, and stars are simply connected, and this show the simplicity of nature in general, because nature is in micro and macro scales can be described by simple formulas of the same kind. Thank you. Thank you.
Thank you very much.